Hello, I'm David McLeod from South Africa's Centre for High Performance Computing. In this video, I will demonstrate the KVM SR-IOV VMM driver, which enables native Infiniband support in virtual machines deployed through OpenNebula. To start, let's take a look at the KVM SR-IOV VMM directory. This directory is very similar to the one which ships with OpenNebula. The only superficial difference is the addition of the VF-maps directory and a script. There are also a few additional configuration options which you'll need to set in KVM RC. The first important setting is the dummy bridge. This is the bridge to which you want the libvirt dummy interfaces to bind. These interfaces are just used to pass IP address information into the virtual machine for the SR-IOV devices. They are not used for the transmission of any data. This bridge can be a bridge to nowhere, it just needs to exist. Another important setting is the dummy MAC prefix. The MAC prefix needs to be distinct from the OpenNebula default prefix. This prefix is used to distinguish between dummy interfaces for SR-IOV IP address passing and the libvirt interface which the user creates. Let's take a look at the VF-maps directory. Inside the VF-maps directory, you'll find an example IB0 map file. The map file contains the bus, slot, and function addresses for each virtual function which you want the driver to use. Each line in the map file represents a single virtual function. To learn how to extract the VF addresses, have a look at the documentation. It's not difficult to find the VF addresses, but be aware that the numbering varies from manufacturer to manufacturer. For example, this device is increasing sequentially. For some dual port cards, the addresses will be interleaved per port, and still with some other cards you can specify the number of virtual functions per port, so they may be different. Because of these inconsistencies with the numbering, we leave it up to you to decide which virtual function is associated with which physical port. Once this is complete, you can then move over to OpenNebula to create a host to use this custom driver. Creating a host is just like any other VMM driver. Except you just need to choose custom and specify to use KVM _ SR-IOV. Take note that if you use a network which supports network isolation, that network isolation will not work for any SR-IOV based devices. This is because the SR-IOV based devices directly access the hardware and therefore bypass the user network isolation. Once you have set up your host, you can click create and you'll get a host that looks something like this. As you can see, this host has been set to use the KVM _ SR-IOV VMM driver. With that in place, you can now create a virtual network. Once again, it's very similar to the standard procedure. You fill out the network form as you would, except the bridge field must now be prepended with SR-IOV and an underscore, and then you specify the map file which contains the virtual function addresses which you want the driver to use for this network. So in this case it is IB0. As I say, everything else is as usual. Click create and you'll get a network that looks like this. So as you can see, this Infiniband network is using the SR-IOV IB0 map file, and its network range is 10.1.20. Now that we have a host and a network, we can create some virtual machines that use Infiniband. So here are two previously created templates with Infiniband interfaces in them. I'll instantiate two of these and just one of these. So if you look at the virtual machines, you see I have our 3 virtual machines running. These 2 virtual machines have a single Ethernet normal libvirt interface and an SR-IOV based Infiniband interface. And then this virtual machine here I just created to show you how the driver handles multiple interleaved networks. So here we have Ethernet network, and an Infiniband network, and then an Ethernet network, and then an Infiniband network. You could also say it's a libvirt device, and then an SR-IOV device, and a libvirt device, and an SR-IOV device. While these virtual machines are starting, I just want to take a look at some of the OpenNebula controls. All of these controls will work, but some of them require that SR-IOV devices be hot plugged. These are the ones which require the VMM command save. For example, suspend, stop, migrate, and migrate live. So what has to happen here is the SR-IOV devices associated with the virtual machine have to be hot unplugged before these operations are executed, and then upon completion of the migration, or once you click the restore button, the virtual machine has to have these SR-IOV devices hot plugged back into them. So this may cause some inconsistency with the operating system, with these devices suddenly disappearing and reappearing on them. I have tested this with CentOS 6.4 and it seems to be okay with this. I'll give a migration demonstration later on. So let's just see how our VMs are doing. So it looks like they have started. So now let's SSH into one of these virtual machines and have a look at the devices that are available. So and if you run the IP adder command, we can see the first device is the Ethernet device. This is .49, which we SSH'd in on. As you expect, it is in the first place because it was the first device we attached to the virtual machine. The second device is ETH1, and this is also an Ethernet device, except you do not ask for it. But we can see from the MAC prefix AA that this device was added by the driver to pass IP information through for the SR-IOV interface. And you can also see that it is in the down state, so we're not actually using it at all. Then you see the IB0 device. This is the SR-IOV device that has been passed through into the virtual machine. You can see that its IP address is 10.1.20.49 as we requested, and you can see that that address came from the down ETH1 interface. So now that we have an IB device inside a virtual machine, let's see if it actually works. So to do this, I'll be using the IB send latency test. So I'm just going to bring in another terminal and SSH into the second virtual machine, 192.168.0.50. And on this, I'll run IB send lat, and I use the -r command to specify RDMA Q-pair exchange. Okay, so now that's waiting. Let's get that out of the way. Over here, I'll run the other side of the command, IB send lat -r as well, and I'll tell it to communicate to 10.1.20.50. Execute it, and we can see we have a successful test. Latency is around 4 microseconds. It used RDMA Q-pair exchange. Its transport type was Infiniband. This is clearly just been some Infiniband communication between two virtual machines deployed through OpenNebula. So there's the proof that it works. Now that we've done that, I just wanted to show you that third virtual machine that I deployed, 192.168.0.51. If we look at its IP addresses, you can see there are a lot more. In the Ethernet position, we have the first Ethernet device that we asked for on .51 as expected. The second Ethernet device, ETH1, is .52, but if you remember, this is actually the third interface that we specified. The second interface was an Infiniband interface, but you can see the driver has correctly resolved the order so that the Ethernet devices which the user requested are first, and then you can see ETH2 and ETH3 are the AA prefixed MAC addresses, so these are the dummy interfaces. It put them last, and you can see that they are in the down state. And if you carry on looking further down, you see the first IB0 device with IP address .51, which is associated with this ETH2 device over there. And then we go down some more and you see the second InfiniBand device, and its IP address is 52, and that is associated with the ETH3 dummy device with .52. So this driver will always attempt to resolve the interfaces into intelligible order, with the user created Ethernet devices first and then the SR-IOV dummy interfaces second. But there is a situation in which this gets a little bit broken, and that's if a user tries to hot attach a device. So we can have a look at that example quickly. So on this big virtual machine over here, I am going to request a hot attachment of a network card, and we will first attach a normal internet Ethernet card. So now if we go back in here and have a look at what's happened, we can see that an ETH4 has been added in, and it's right at the bottom. Unfortunately, there's no way to insert in the middle because of the way the operating system keeps track of the interfaces. But then you'll just have to be aware that any user attached interfaces after the virtual machine boots are going to just be up to you to resolve correctly. This starts in the down state anyway. So now what I'll do is show you what happens if you attach an Infiniband device. So we go back to OpenNebula and refresh this. I'm going to attach an Infiniband network. Let's have a look at what's happened. I suppose I should clear the screen first. All the same at the top. There's now an IB2 interface and an ETH5. It's put that at the end again, and you can see that it's 35 to suggest the IP address which IB2 should get. So you could have a script that would read this information and associate it correctly with that device. But resolving the order becomes a lot more complicated, and you'll have to do that on your own. You can also hot unattach if you want. So just refresh this again, and it's hot detached InfiniBand, and hot detach the additional Ethernet interface I added. Have a look at this. And we can see we're back to where we started. We have the original ETH0 and ETH1, the two dummy interfaces, and then two InfiniBand interfaces up on the respective IP addresses associated with the dummy interfaces. So that shows how the positions of all the interfaces are resolved. Nothing too complicated about that. Let's now take a look at some of the more interesting functionality like migration. So I'm going to start a ping here on 10.1 to 20.49, which is one of the first virtual machines. So there we go. Then what I'm going to do is take this .49 machine and do a live migrate onto node 1 from node 6. And let's have a look at what's going on. So you can see migration has started. The SR-IOV interface has been hot unplugged. It's now making its way onto the node 1. Once it gets there, the driver will attempt to reattach the device. There we go. And now it is running on node 1. So if you go back and look at OpenNebula to confirm that, there we go, it's now running on node 1. So you can quite happily migrate these virtual machines around the network. You can also suspend them. So you see now it's been hot unplugged. The virtual machine is no longer available. We've now entered the suspended state. You can then resume. The virtual machine will come back up. You need to be aware that if you suspend a virtual machine, it will remove the locks that it has on the virtual functions that were associated with it, and then when you use the restore function, it will attempt to reacquire locks. If there aren't enough locks available, restore will fail and will go back into the suspend state or the stop state. The only somewhat dangerous function here is actually cold migrating. Now the reason why this is problematic is because it uses the save and restore functions. So if I migrate it to node 2, what actually happens is it puts it into the save state, then the back end of OpenNebula specifies the host which it must go to and does a restore onto that machine. The problem is that it doesn't pass through the VMM scripts the destination machine. This means that it has to attempt to restore blind, and unfortunately if it fails, it doesn't put it into a suspend or stop state, it puts it into the failed state. So you would have to manually recover. Because the live migrate function has its own special scripts which are aware of the destination host, this driver will attempt to acquire locks remotely before moving, and if it fails, it can recover back to the source. So live migrate is actually a lot safer with this driver than cold migrate. So that is it. This driver only has one drawback, and that is that it doesn't support network isolation for the SR-IOV devices, but in exchange for that drawback you get much better performance on the SR-IOV devices, and you get native support for Infiniband in the virtual machines. Thank you for watching the video. Goodbye.